What is up, friends? I don't know if we're live. Are we live, ladies and gentlemen? Anybody pop in here and let me know if we are good to go and live. I am curious to see if this has worked because I've got a bunch of tabs open right now and I want to make sure that we're live. I'm going to test this on a thing. Just for anybody who can hear me right now, who's in here, if anybody's in here, we're popping in just to say hello. This is a new Dino live chat for the week. This is sort of like a weekly show that I want to try to do on this. So you can kind of treat this like a podcast if you're watching it later. If you're not watching it live when it's happening, it's all good. No worries. Hey, we got Andres in here. Can you hear me? Is the audio sounding good? Let me know. I'm going to try this out on my phone just to make sure to verify that you can hear me. Let's see. Just trying to confirm it. Let's see. Oh, dope. Sound great. Okay, fantastic. Yeah, guys. So welcome to another Dino live chat. Treat this as a podcast. I want to make a little announcement here at the beginning of the show. I'm just going to move this tab over so I can see you guys over here. Treat this as a live show. Treat this as sort of a podcast. Listen to this when you're driving to work, when you're on the train, whatever you're doing. Pop in here, enjoy this later on. And most importantly, guys, the channel currently has like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe like almost 20 playlists that I created just for you guys. For anybody who's listening to this now or later, for you to easily binge watch the Dinosaur channel content. We have it organized by species. We have it organized by Jurassic Park movies, by live streams, whatever you want. Everything's organized in here. We're going to go live here real quick and talk to you guys about some fantastic dinosaur news that we have for the week and for the month and for the year. Some stuff that I've wanted to talk about that I never got around to talking about. Also, I see Nikki Dunn here messaging, did you see the link I added to the Mexican dino? I have not. Link it in the chat right now and we can talk about it for sure. I want to go over with you guys about some cool dinosaur finds on Science Daily, and one of them, which was really, really, really impressive, that actually happened while I was on. So I've mentioned this in other episodes prior, but I was actually living on a small island in the Philippines when a really big typhoon came to the island and destroyed the island. And while the island was in the process of being destroyed by this typhoon, the 3 weeks of recovery, I had like very little internet, wasn't really in touch with what was going on in the world. And I remember when I finally got internet again, I got a bunch of people messaging me and sending me articles about this really, really cool find that happened just recently, which is a preserved embryo of an Oviraptor. I don't think it was exactly a Oviraptor, but an Oviraptor. That was like perfectly preserved, the fossil of an Oviraptor. It's one of the best preserved baby dinosaurs ever. And as a big fan of baby dinosaurs myself, this is amazing news. So one other thing that I want to touch on, guys, is something that's very exciting for anybody listening now live or later. If you follow me on social media, you can follow me on Twitter at the Dinosaur Chan, or anywhere you can find me on social media. You would have known that I made a pretty stellar purchase just yesterday. Show you guys a picture through the screen just so you guys can see what it looks like. But obviously, this is going to warrant an entire video series. My friends, I have a Jurassic Park Jeep in my possession, which is insane. It's a fully done up Jurassic Park Jeep Wrangler from 1992, 1993, and it's amazing. And I bought it specifically for this channel and in a really epic series that we're going to be doing with it this summer. Obviously, you guys are the first to hear from it that are on this live stream. It's very exciting. But yeah, this is something that I have in store. So obviously, if you're listening to this podcast and your pockets go any deeper and you want to support the channel, sending us money on PayPal in the links down below in the description is a big way to help out the channel right now. I'm not currently monetized, so I'm not making any money from these videos because YouTube removed monetization on this channel. So any sort of donations, contributions you can make to the channel, if you can make any, would be much appreciated through PayPal to help fund this insane Jeep that I had to pay for, and it's very expensive. That being said, I'm really excited about it. It's gonna be insane. I'm hoping to create a series about dinosaurs this summer that is unlike anything anyone has attempted to do ever. I'm gonna take everything that I know, all the knowledge I know about creating travel content on YouTube, for my full-time travel channel, and I'm gonna bring it to this dinosaur channel and give you guys something that's truly unforgettable and that hopefully make some moves on YouTube, and puts the dinosaur channel on the map. That's what we're going for. So I mean, I don't know if it's going to happen, but with your guys' support, obviously the people watching the stream and the people who are watching later, anybody who supports this channel, um, the more of you guys watching, the more of you guys supporting. I think we got like almost 1,000 views. Yeah, 740 views on the last live stream. You guys are freaking incredible. So if anybody's listening to this after the fact, if it's anywhere near 740, I'm going to keep doing this every single week. Because the more of you guys watch, it just keeps me going because I really, really love this content and I love talking about dinosaurs. All right, 5 minutes of rambling in. Let's talk a little bit about this exquisitely preserved embryo found inside a dinosaur egg, fossilized dinosaur egg. So I'll send the articles every time that I talk about them so we can review together if anybody's interested. But this has got to be one of the coolest finds I would say of the century, of the decade for sure. It's a perfectly preserved Oviraptor. So Oviraptors are dinosaurs we haven't covered on the channel quite yet. I will always leave a playlist leaving on my after I leave a live. You're so amazing, Nikki. I appreciate you so much. Honestly, it's kind of I'm not allowed to really promote that according to YouTube's terms and service, but I do appreciate it very much. So yeah, more people who can do that would be amazing. Nikki was saying I will always leave your playlist playing on my laptop after a live. Very much appreciated. Yes. So in regards to this embryo, so Oviraptors, we haven't talked about them yet. If I remember correctly, their name comes from egg thief, and we do have a dinosaur quick dive coming on them in the future. So Oviraptorosaurs are known as egg thieves. They were originally found in China, I believe, or in Mongolia, and they were classified as dinosaurs. So they were always found near eggs of other dinosaurs, which is what paleontologists back in the day thought. Paleontologists back in the day, when they discovered dinosaurs, they never really attributed good parenting skills to these dinosaurs, especially like animals like the T-Rex, the Iguanodon, Triceratops, these first dinosaurs, Stegosaurus. When they first found them, they attributed them to be these big, lazy lizards, cold-blooded, didn't have any parenting skills, couldn't be warm mothers. So when they found oviraptors near clutches of eggs or destroyed eggs, they assumed that the oviraptors were specialized in hunting eggs or stealing eggs, thieving eggs from different nests of different dinosaurs. And the reality is, after decades of study on these fossils and these dinosaurs, it comes out that oviraptors were actually just very good nesters, brood nesters of nests of their own kids, of their own children. So there are multiple species of oviraptors. If I'm not wrong about that, this one is specifically dubbed Baby Ying Liang. It was discovered in late Cretaceous rocks of Guangzhou, southern China, and belongs to a toothless theropod dinosaur, or Oviraptor. So oviraptors, what's really cool about them, presumably, most paleontologists assume that these guys were covered in feathers. These are one of the most bird-like dinosaurs that we have. Why? Because for most of the species, if I remember correctly, I could be wrong. I'm not a paleontologist, so I don't know all this information off the top of my head, but from most knowledge that we have, these dinosaurs did not have teeth in their beak. It was just a beak, I believe a keratin beak. So very, very, very bird-like, like what we consider non-avian or avian dinosaurs that we have today in this world. So a little bit to go over that. In modern birds, such postures are related to tucking, a behavior controlled by a central nervous system critical for hatching success. After studying egg and embryo, researchers believe that such pre-hatching behavior, previously considered unique to birds, may have originated among non-avian theropods. So this idea, and there's specifically what they're talking about, is previously unrecognized in dinosaurs. This posture is similar to that of modern bird embryos, which is scientists have been trying to find a distinct link between paleontologists specifically between birds and dinosaurs. So non-avian dinosaurs and avian dinosaurs. The link between them, we know it's there. We see it between certain bones and the morphology of theropods specifically. Dinosaurs like Ornithomimus, like that genus or that family of dinosaurs, Ornithomimosaurs, hadrosaurs, like we talk about dromaeosaurs, raptors, tyrannosaurs. The link between birds, between an ostrich, a cassowary, an emu, a moa bird, to these species of dinosaur, these types of dinosaurs, it's not that far. And so when we're looking for links between them, what's really exciting is a dinosaur like this showing that tucking. So I'd really suggest anybody listening to this podcast, if you're driving, obviously right now, don't do that. If your hands are occupied, don't do that. But when you get a chance, look up the title of this article, "The Preserved Embryo Found Inside a Fossilized Egg," and you'll see a bunch of great pictures, one of a render and one of the actual fossil of this dinosaur tucked up in the egg, like what you would assume a modern day chicken is like in an egg, or a duck, or an ostrich, or whatever. Um, and this is so exciting for paleontology, because the link between these dinosaurs and these birds is becoming clearer and clearer, and we can see through animals like oviraptors that I'm pretty sure lived in the Cretaceous period. Don't quote me on this, but I'm pretty sure this species of dinosaur existed only in the Cretaceous period. um I'm pretty sure, yeah, Cretaceous of Asia and North America. So I was right about that. A dinosaur channel. Be weird if I didn't know that information. um we're getting close to the end of the Mesozoic era. We're getting close to the end of the dinosaur era, and we're seeing links, really distinct links. I mean, we're not talking about a Brachiosaurus or an Apatosaurus from the Jurassic period. We're not talking to you right now about a Giganotosaurus or a Spinosaurus. While those are more bird-like or duck-like, whatever you want to call them, we're talking about a dinosaur that lived at the end of the Cretaceous period, who was probably fully feathered, with a beak, no teeth, and behaved very similar to what you'd expect a modern day ostrich or a moa. Maybe, who knows, maybe had more intelligence, more whatever, more social skills. But that's so cool, because that means that link, that distance is not so far away, um, like what people's assumptions were about dinosaurs when they first discovered them. Furthermore, in the article, it said baby Yingliang was identified as an Oviraptor based on the deep, toothless skull. Oviraptors are a group of feathered theropod dinosaurs closely related to modern-day birds, known from Cretaceous for the Cretaceous period of Asia and North America. Their variable beaks and body sizes are likely to have allowed them to adopt a wide range of diets, including herbivory, omnivory, and carnivory. I hope I'm pronouncing that correctly. Um, which is also very exciting, because, as we spoke about earlier, with the egg being dubbed the egg thief, or the egg thief genus or species or whatever it is, uh, these dinosaurs were sort of plastered when they were discovered as these guys ate eggs. These guys stole the eggs from other nests of dinosaurs, and they do what they do with that. But what's nice to know is, like modern day birds, which a lot of birds are sort of, I mean, a lot of them are specialized, especially when you go to places like, let's say, Galapagos Islands off of the coast of Ecuador. You see finches that are hyper specialized in eating this specific berry or this specific nut. When we talk about the larger birds, the birds that we most likely relate to dinosaurs, you do see a varied diet. Sometimes they're eating seafood. Sometimes they're eating, food from brackish water, so it could be any sort of marine life. Sometimes they're eating reptiles or eating mammals. Sometimes they're feeding on fruit. Sometimes they're feeding on plant matter, which I don't think is very common for modern day birds to be eating plants. Don't quote me on that, but I don't think that's something that's very common. Um, but this is a really impressive, because a dinosaur like this, which we assume to be a pretty successful dinosaur, I'm pretty sure there's quite a few fossils, well-preserved fossils of Oviraptors found around the world. It only goes to claim that this was probably a pretty successful dinosaur, which means in the matrix of the fossil record, we're able to find lots of fossils of them, which probably means this was a dinosaur that was very plentiful, probably pretty smart, probably lived for a good few million years, evolved really beautiful traits. I mean, assumed it was probably a very beautiful animal too, covered in really, really nice plumage, probably had good social skills and interesting breeding behaviors, something to really see. It would have been an event to see an animal like this live. Um, let's see what else we have here. Professor Lida Xing from China University of Geosciences in Beijing, joint first author of the study, said this dinosaur embryo was acquired by the director of Yingliang Group, Mr. Liang Liu, as suspected egg fossils around the 2000s. So this was found in the year 2000, so a very long time ago. Mr. Liang Liu, as suspected, during the construction of the Yingliang Stone Nature History Museum in 2010, museum staff sorted through the storage and discovered the specimens. The specimens were identified as dinosaur egg fossils. Fossil preparation was conducted and eventually unveiled the embryo hidden inside the dinosaur egg. This is how baby Yingling was brought to the light. So it's funny sometimes in paleontology when you discover things, when these scientists discover things, they don't even know what they have on them. I'm pretty sure, if I remember correctly, I mean, I should know because I'm reading this article right now, but I'm pretty sure that they did not know that this dinosaur was in this egg for a long time until they decided to open it or crack it or something, or the people who had originally found it didn't take a second to think that there might have been a dinosaur preserved in here before. Um, I think just by the way that I'm looking at the picture of the egg, I don't think that's a natural cut line around. I'm pretty sure they probably cracked this egg and opened it to see what was inside, because I don't think a fossil would have preserved in this way. I mean, it'd be very odd if there was a slit right through the middle of the egg, just perfectly showcasing the baby dinosaur inside. So I'm going to go ahead and say, the scientists probably opened this up to see what was inside. But it's an amazing discovery, not just for China, but for the paleontological world in general. So cool that we get to see things like this that are, that are spreading more and more cool dinosaur information and facts around the world. So that's great. That's our first article. Highly recommend anybody to go over to Science Daily, I believe is the website. Yeah, they have a whole dinosaur section here on this website. It's been great. I've been getting dinosaur news from here since I was a little kid. Highly recommend if you ever want to keep up. Because it's dinosaurs and there's not so many discoveries happening on dinosaurs every single day. The highlighted ones, usually a little far and few in between, but there's always interesting stuff coming out on the realm of paleontology. So next up, I want to talk to you guys about a new identified softshell turtle that lived alongside T-Rex and Triceratops. So this is a species of turtle, softshell turtle. So if anybody knows, and if you don't know, if you're looking this up, again, take caution if you're driving or if you can't use your hands right now while you're listening to this. But highly recommend, if you don't know what a softshell turtle is, I highly recommend you look it up. So let's talk about softshell turtles. They're pretty much, I would say they're generalists, but they're highly specialized in certain degrees of things that they do in the water. Now, again, I'm not a biologist. I'm not a wildlife zoologist. I'm nothing like that. I'm just, I'm curious and I love animals. I love the wild. I love turtles specifically. I love turtles, if anybody knows that meme. And I love dinosaurs. So I like to study the relationship between these animals. To give some context about my love of turtles, I actually used to own a softshell turtle. I had it as a pet for many years in my apartment when I was a kid growing up, until I released it into a lake because they are native here in Florida. And I don't think it was an invasive species, if I remember. I'm pretty sure it was a Florida softshell turtle. So this turtle is a turtle which is its carapace is completely soft. It's like you could press on the thing, it's like jelly. And they're commonly eaten in a lot of places around the world because they're so easy to consume. And that shell, or the carapace, whatever you want to call it, it's not like bone. It's not calcified. It's not hard. It's this very easy thing to like cut open, rip, and eat the internal organs. So these animals are hunted and eaten. I don't think they're endangered in any sort of sense, but that's just to give some context. We still have them around today. So if you want to see what a softshell turtle is, they're pretty cool. They have these long snouts that come out. Not like a normal turtle. They have sort of these long Pinocchio noses. Really, really beautiful animal, especially when they get really large. They have these large flippers with lots of sharp nails. And they spend most of their life in the water, usually in either brackish or fresh water. There are none that I know of that live in the salt water. So here we go. This is the article. A newly described softshell turtle that lived in North Dakota 66.5 million years ago. So right there at the cusp, at the end of the Cretaceous period. At the end of the Cretaceous period, just before the end Cretaceous mass extinction, or as we know, the KT extinction, it's one of the earliest known species of the genus, according to the new research shared in the journal Cretaceous Research. So the scientific name, apologize in advance that I can't pronounce this correctly, Hachemis wacklerium, lived during a period when large and well-known dinosaurs also roamed the earth, including Tyrannosaurus rex and Triceratops. The find adds important information to scientists' understanding of softshell turtles more broadly, including potential effects of the end Cretaceous mass extinction, which took place in the same period, on their evolution. Let's see here. So this turtle belongs to the particular group of softshell turtles in the Trionychidae family called Plastomeniaceae. These turtles are similar to softshell turtles that exist today, although the plastron of the Plastomenian turtles, the bones covering their stomach and abdominal area, are most strongly sutured together and often larger and more robust than any other softshell turtles. So that's really interesting. As I was explaining to you guys earlier, softshell turtles, the entire carapace and the plastron, which is the bottom section. So carapace is the top of the shell of a turtle. This goes for any turtles, sea turtle, tortoises and like marine turtle, or not marine turtles, but freshwater turtles, whatever kind of turtle, just a turtle. I think that's what those are called. You have the plastron on top, no, the carapace on top and the plastron on the bottom. So what they explain in this is that the differentiation between these soft-shell turtles that lived in the Cretaceous period is that plastron, the bottom of the shell where it connects to the stomach, and this is really where all the internal organs are kind of glued to in the bottom. So if you imagine the inside of a turtle, and I guess this goes way back into like prehistoric turtles as well, that shell is a case, right? The shell is a case where the turtle can kind of duck into a little bit, but not fully. But it's a case, and the reason that it's a case is to keep everything that's important of the turtle protected. So it wants to keep all of its internal organs protected in a sensitive, safe area. So with sea turtles, marine turtles, or normal turtles that have hard shells, they're able to store all this stuff inside of the shell and pretty much evade predators. So a predator wants to get them, they'll have to rip off a limb or something, and still most likely they'll be able to survive and live their life without that limb. And they won't get any sort of damage from internal organs or anything really life-threatening because they have that hard shell. It's one of the best, most successful protective devices in the animal kingdom. And you can see, divergent evolutionary. I wouldn't say it's exact, but in the similar realm of having that armor plating on things like the ankylosaur, or the Ankylosaurus family. You have animals like Polycanthus and nodosaurs, similar to the armadillo, to the pangolin. These are all animals that sort of evolved similar traits. It's not exact, it's not the same, but having a hard shell to protect your internal organs give you the opportunity to roll up into a ball, to evade predators with a hard calcified shell on the outside of you. Duodecarus, I think it was what it's called, is sort of like the ancient giant armadillo of the day. This is an amazing trait that evolved. And so what they're explaining, long story short, is that the carapace or the plastron of these ancient softshell turtles were actually harder. And maybe that comes from evolution when the animals were evolving down or evolving to different subspecies, or this might be the beginning of that evolutionary line of softshell turtles. They were still becoming less soft or becoming more soft as it goes by. So from turtle to turtle, that plastron on the bottom was becoming softer and softer and softer. And here it's still relatively hard. So that's a cool article. It's nice to know. It's cool to know that these could have potentially have been, prey items for dinosaurs in the Cretaceous period in North Dakota, specifically in North America. Very, very exciting news to know that there was a new identified species of softshell turtle back then. So let's go up. We have another article. This one's a little bit older. It's from December of 2021. So it says sauropod dinosaurs were restricted to warmer regions of Earth. So this is really interesting because as our grasp of dinosaurs and where they existed on planet Earth expands year to year, and I bet you guys, everyone listening to this right now, I want you guys to keep this in mind and keep an eye on my channel, because I think this is something that we are going to start talking about as a community of dinosaur lovers in this world, and people who are interested generally in dinosaurs and paleontology. We're going to start seeing this in the mainstream, and we're going to start seeing people talking about this more seriously after June. What happens in June? In June, a little film, maybe a little indie film you guys have never heard of, called Jurassic World Dominion is coming out. Now, Jurassic World Dominion is introducing us and putting dinosaurs in the mainstream in environments we've never seen them before. In the desert, in snowy environments, in swamps. These are things that we've never really seen in the mainstream because, let's be honest, Jurassic Park has pushed the narrative of dinosaurs from, the late 90s or the early 90s till now. And most people's relationship, even if it's just a slight bit, has some sort of influence or has been influenced by Jurassic Park in some sort of context. And up until now, almost our entire context of Jurassic Park or dinosaurs in these movies, films, and other contexts has been in a tropical island environment. And the reality is, while the world was warmer back in the Mesozoic era, for sure, through the Triassic period and Jurassic period, it was pretty tropical, most of the world. I don't think that there was much snow and there wasn't much varied environments back then, especially towards the tail end of the Cretaceous period. The world was diverse. There were snowy mountains. Dinosaurs lived in snowy areas, and that's just a reality of the situation. And they probably evolved a bunch of evolutionary traits that we don't even think about And we don't even imagine, because we just imagine them still in this narrative of lizards living in tropical climates. Now, this is an amazing article. Why? Because it's touching on this. And just to touch back onto that point of Jurassic Park pushing that narrative, in Jurassic World Dominion, if you watch the trailer, we're opening up multiple scenes of dinosaurs in the desert and dinosaurs in the snow. And I bet that we're going to start seeing the conversation being pushed furthermore about, and we're going to start seeing this also in an artistic perspective of dinosaurs in varied environments, not just in the jungle. Don't get me wrong, I personally love seeing dinosaurs in what I imagine their natural habitat, being the jungle, being the rainforest, being, deep in a desolate rainforest, somewhere where you can imagine them in a swamp, warm, volcanoes, whatever you imagine 65 million years ago, 66 million years ago, the world looking at like. But I love the diversity of it. I love to imagine dinosaurs with a thick coat of feathers, preparing for the winter, because that's something that happens in the natural world. We have animals that survive the winter, and just because they are reptilian-like or they had scales, for all we know, they could have had fur. They could have had stuff that didn't um, preserve correctly. We don't know. They could have found, and this is going a bit of a stretch, but they could have been smart enough to find technological ways to deal with the world around them when it was cold, when it was snowing, when there was a desert storm, when it was too hot. And we just don't know. We don't have access to that information at the moment. I'm sure we will in the future. Who knows if we'll still be alive then, but I'm sure we will. And that's just really interesting. So let's read a little bit about this article. Again, all these articles can be found on Science Daily, so huge shout out to them and their articles. It's very cool that we can access this and get cool information and news about dinosaurs. So it says, giant long-necked sauropods, thought to include the largest land animals ever to have existed, prefer to live in warmer, more tropical regions on Earth, suggesting they may have different physiology from other dinosaurs, according to a new study. Now, this makes sense. Just to open up, of course, this makes sense. This is a massive animal, right? Sauropods are bigger than any other animal group that we've ever discovered. I think besides the blue whale, which I think is still to this point the largest animal to ever have existed, ever, sauropods are animals that reach hundreds of feet in length. I mean, not hundreds. I don't think anything has ever surpassed the 100 mark, but 100, 120, 110 feet long, 80 feet high, crazy big animals that they grew in rapid growth from year to year, from hatchling to subadult, juvenile to adult. These animals grew like this, and they probably lived very long lives, very slow moving lives that predominantly revolved around consuming gastroliths, which if you watched our channel before, you should know what it is, but just as a refresher to people who haven't, gastroliths, it's something that still happens nowadays. It's something that herbivores do, where they consume rocks or stones or pebbles, and they help grind up plant matter in their stomach. When you're a large animal consuming giant quantities of herbivorous foliage or whatever it be, whether you're doing fern pines or leaves or whatever it is, having these gastroliths in your stomach to help you grind up this plant matter in your stomach while it's digesting aids in that process generally. It makes everything a little bit more fluid, helps that coprolite come out very nice and delicious. And it's something we see in the modern day. I think we see it in elephants and other herbivores. We see them consuming gastroliths. And we know this because we find in the fossils of these dinosaurs, we find these massive boulders and stones in their stomach. So giant long-necked sauropods thought to have existed, the largest land animals to ever have existed, prefer to live in warmer, more tropical regions on Earth. The study, published in the journal Current Biology, investigated the enigma of why sauropod fossils are only found at lower latitudes, while fossils of other main dinosaur types seem ubiquitously present, with many located in the polar regions. So in the polar regions of the Earth, so we talk about the polars, it's like North Pole and the South Pole. Obviously, the continents where they are now is not where the continents were back then. I highly recommend you look up a map so you can see what the world looked like in the Triassic, Jurassic, and Cretaceous period. As the continents drifted and got to where they are now, the continents were in different places. So we actually know that there's proof that most likely, if it wasn't snowing all the time or super snowy environments, alpine environments, tundra environments, there were environments that were significantly colder in the North and South Pole of planet Earth. And so apparently, according to this article, sauropods weren't ubiquitously found in these regions. So the researchers analyzed the fossil record across the Mesozoic era, lasting from 230 to 66 million years ago, looking at the occurrences of fossils of the three main dinosaur types. Sauropods, which includes Brontosaurus, Diplodocus, Brachiosaurus, Amargasaurus. We love sauropods on this channel. One of our favorite group, Mamenchisaurus. They compared theropods as well. So lizard-hip dinosaurs. These are dinosaurs that include velociraptors, Tyrannosaurus rex, ornithomimuses, struthiomimuses, and triceratops, combining the fossil data with data about climate throughout the period, along with information about how continents have moved across the globe. The researchers concluded that sauropods were restricted to warmer, drier habitats than other dinosaurs. These habitats were likely to be open, semi-arid landscapes similar to today's savannas. Now let's talk about that, because this is so exciting, because one, it gives us an image of what the prehistoric world probably looked like. If you were to go to the poles nowadays, what are some of the big animals that we see there? In the South Pole, for example, the only large animals we really find, I think, are polar bears. Do polar bears even live in Antarctica? I'm pretty sure they do, right? Polar bears in Antarctica. I might be wrong about that. I know they live in the South Pole. Mm. Oh, okay. The Arctic and Antarctica. Most bears live in the northern hemisphere. Polar bears are no exception. Arctic and Antarctica, while similar habitats in some ways, are home to very different creatures. Both poles host a variety of seal and whale species, but only the Arctic is home to the Earth's largest bear, the polar bear. So yeah, obviously, I think I knew that. That's what I was questioning. I don't think polar bears ever made it down to Antarctica. But the large animals that we see in Antarctica in super, super cold, frigid climates, usually very small animals. The only big animals that we see living in and around Antarctica are animals like the killer whales, narwhals, leopard seals. These are animals that live predominantly in the water, who have evolved specific traits to allow them to live in the ocean and can venture out to warmer waters. I think the largest animals we see in Antarctica are penguins, if I'm not wrong. These colder climates don't really allow for huge animals to develop. Same thing with the Arctic. If you think about it, I mean, when you get super, super north in the North Pole, I mean, we can see moose, some caribou, some elk, but they're not massive building-sized creatures. If you think about a sauropod trying to develop, trying to evolve, trying to live its life in a super cold climate, imagine how much sun, how much vitamin D it probably needs to require for a healthy lifestyle, for a healthy development, and not only that, to survive eating foliage, eating predominantly plant matter. How difficult that would be to attain in a in a tundra environment. It would be near impossible to have an animal that large survive in an area like that. So this article definitely makes sense, and it's helping us shape the world that the dinosaurs lived in. And what I love about articles like this, one thing that's so cool is that this is information that wasn't like, oh, all of a sudden they discovered a sauropod fossil in Africa that gave them an indication that dinosaurs lived in Antarctica. What's really, really cool about this is that, by the way, guys, I'm just going to take a pause real quick in my rambling. If there's anything you guys want to ask or talk about, please put it in the chat right now. I see that there's a few people in here. Would love to hear from you guys. Obviously interacting. I see everyone saying hello. Hi, June. Hi, Hidden Ghastly. Mitch, hello. Nikki, of course, and Andres. Thanks so much for joining us here in the chat. Brian, thank you guys for being here. But yeah, the cool thing about this article is it's not like it's giving us this shocking new information. It's giving us information that is being deduced from scientific information that kind of already exists there, and paleontologists are going in and collecting those pieces of the puzzle and giving us a better image of what we can imagine the prehistoric world looking like. And that's so, so cool, because as we keep, imagine it's sort of like a pickaxe at a rock, like as we keep chipping away, eventually we're going to chip everything away, and we're going to have a really, really clear image of what the world back then looked like. And that will allow us to start shaping, especially when it comes to a fictional narrative, things like Jurassic Park, things like, anything that's going to come in the future that's going to be entertainment about dinosaurs, whether it's a VR game or any video game about dinosaurs, it's going to help us start shaping the narrative of what their world looked like. And I've had what's funny? I've had this question come up a few times recently where people have asked me, especially as I've been talking more about what I'm doing with this dinosaur channel, and how much I am passionate about growing this channel and talking to people about dinosaurs. A lot of people come to ask me, is like, why are you so passionate about these dinosaurs? And I think something that's so cool and that we don't think about on a daily basis, people don't really take the moment to think that there was a whole world that existed here before us. Like while this is the reign of the human beings right now, and we're the predominant species, we're the species who is the smartest, the fastest, the strongest, the most technologically advanced. There was a point in time, way longer than we've ever existed, for hundreds of millions of years, that existed a storyline, a narrative, an existence of an entire species of animal that we've never seen, that none of our species have ever seen, and they lived here for so long, and they ruled this planet, and this was their world. Um, I think for one, it's humbling, and it's amazing to think about and something. It's a daily reminder for me to stay humble and to try to think about these things on a day-to-day basis. Uh, it's just so cool. It's just so cool. And I think that articles like this with sauropods or restricted to warmer climates, it's so exciting for me because it's like, it helps me in my brain start painting the image of what their world looked like, which I'm so curious as to what their world looked like. I want to know what they lived like, what they felt, the things that they saw in their lifetime. Imagine all the extinctions that they went through, the deaths of their species, the rise of new species, the evolution, how it happened, where it happened. It's so amazing to me to read articles like this and imagine a world of theirs. So June is writing here, I'm like kindergarten when it comes to dino. Just here to support to get this channel back on track. Appreciate that, June. Thank you so much, man. I really appreciate it. Or woman. I don't know if you're a man or a woman. So let's see here. This suggests that sauropods had thermal requirements for other dinosaurs, relying more on their external environment to heat their bodies, slightly closer to being cold-blooded like modern-day reptiles. Their grand size hints that the physiology may have been unique. I mean, again, if you know anything about animals, if you think about large animals, this is kind of like a doy moment. Like, of course, it would be very, very hard to keep even if it was warm-blooded, I don't even know how that would really work. How to keep an animal like that moving? Like you think about a body of an animal, of an organic, an organic species, an animal that's moving, that's alive, that's sentient. You think about an animal like that you keep it moving. It's kind of like a semiconductor, like it's a thing. It's like a machine that's moving. It needs to be warmed up and fed consistently. There needs to be energy moving through there. And when you cool things down, you make everything cold. Everything becomes, you have to work double as hard to heat things up to keep them moving. And when you make things cold, you lose most of your plant matter. You're just reducing in size, and you're making it pretty much impossible for an animal like that to exist in that region. So, anyways, that's a really cool article. It gets me super excited. I love it. And the study involved researchers from UCL, University of Vigo, in Spain, I guess, University of Bristol in the UK. Shout out to Bristol, love you. Natural Museum of Natural History, Smithsonian Institute, Washington, and received funding from the European Research Council and the Royal Society. Super cool. What a cool collaboration. Really, really exciting article. Okay, here's another really cool one. This is from March 1st, 2022. This is something that I've been seeing, I think, on sort of some of the channels of Paleo Twitter. Really, really cool, though, article, and very interesting to think about. Tyrannosaurus remains hint at 3 possible distinct species. I don't know if we talked about this yet. Maybe we did talk about this. But if we did talk about this in the last episode, I apologize for repeating myself. But there's been a recent finding with T-Rex where they wanted to name it into 3 specific subspecies. One that was going to be like the tyrant lizard queen, because right now T-Rex is like the tyrant lizard king, and then the tyrant king emperor. I think we'll read about it in a sec. React, it says, keep it going, Tall. You are rare. That's why I follow you. Thanks. React, I appreciate you for being here. And I'm sorry I haven't replied to your email yet. I've been very busy. If you're just joining the live stream now, I purchased this week a Jurassic Park Jeep. I'm really busy. Oh, sorry, that was a Tinder notification. I apologize for that. Yes, I bought a Jurassic Park Jeep, so I've been very, very busy with that recently. So apologize for that. And I will get back to you very soon through the email. I'm just trying to clear my space. And I'm not even home right now. I'm actually at my friend Jack's house. This isn't even my Dinosaur studio. As you guys can see, the background is completely different. So I apologize for that in advance. Okay, so let's see here. A new analysis of Tyrannosaurus skeletal remains reveals physical differences in the femur, other bones, and dental structures across specimens that could suggest Tyrannosaurus rex specimens need to be recategorized into 3 distinct groups or species. Tyrannosaurus rex is the only recognized species of the group dinosaurs or genus Tyrannosaurus to date. Now, again, to make a differentiation, there are tyrannosaurs, which are not Tyrannosaurus. There are animals like Eutyrannus and others. I don't want to start naming them off. I'm probably going to get the names wrong because I don't know all of them off the top of my head. But Tyrannosaurus is a really, really specific species that lived in North America or at the end of the Cretaceous period, the one that we know and love, the one that is pretty much the logo on this YouTube channel, and one of my favorite dinosaurs. So let's see here. The authors observed that the femur varied across specimens, some with more robust femurs and others with more gracile femurs. Gracious femurs. The authors found that 2 times were more robust femurs than gracile femurs were on one across specimens, which suggests that this is not a difference caused by sex, which would likely result in a more even split. The authors also suggest that the variation in femurs is not related to growth of the specimen, as robust femurs were found in some juvenile specimens, 2/3 the size of an adult, and femurs were found in some specimens that were full adult size. Dental structure also varied across specimens, although those with both femur measurements and dental remains was low. Okay, here we go. Of the Tyrannosaurus specimens, 28 could be identified in distinct layers of sediment at the Lancian Upper Maastrichtian formations in North America, estimated to be from 67 to 66 million years ago. The authors compared Tyrannosaurus specimens with other theropod species found in lower layers of sediment. So I want to see here whether we're trying. Okay, here. The author nominated 2 potential new species of Tyrannosaurus based on their analysis. The first, Tyrannosaurus imperator, which is tyrant lizard emperor. Yeah, this is exactly what I said. So if we didn't talk about this, this is super exciting news. So the Tyrannosaurus imperator, so the tyrant lizard emperor, relates to the specimens found at the lower and middle layers of sediment, characterized with more robust femurs and usually 2 incisor teeth. The authors argue that these features would have been retained from earlier ancestors, Tyrannosaurids. And then a Tyrannosaurus regina, the tyrant lizard queen, is linked to a specimens from the upper and possibly middle layers of the sediment, characterized with slenderer femurs and 1 incisor tooth. How cool is that? I don't know how I feel about it per se. Having my good old T-Rex that I know and love split into 3 different species. I mean, that means that probably some of the Tyrannosaurs that have been found in museums are going to now all of a sudden not be T-Rex anymore, and they're going to be Tyrannosaurus regina or Tyrannosaurus imperator. I think it's amazing. I think it's so cool. It's so exciting that findings like this are happening and that the paleontological community is making these differentiations, especially in a species which is regarded as the most famous dinosaur species of all time. It's just so exciting. I don't know. I'm really excited about this. I know it's probably a nerdy thing to nerd out about, but this is a channel devoted predominantly to dinosaurs, so probably the appropriate place to be nerding out about this. So let's see here. The recognized species Tyrannosaurus rex was identified in the upper and possibly middle layer of sediment, with specimens classed as retaining more robust femurs while having only 1 incisor tooth. Some specimens cannot be identified based on their remains, so were not assigned to a species. I don't know. I love this article. It gets me excited. It gets me super pumped for more news to come out about the T-Rex. T-Rex is I, as a dinosaur lover and somebody who is trying to build a career in dinosaurs and paleontology, it feels sometimes weird having the T-Rex be one of my favorite dinosaurs, or like pretty much up there as my favorite dinosaur, because it's the most boring answer. Like, everybody loves the T-Rex. When you ask somebody what their favorite dinosaur is, like 9 times out of 10, they'll say T-Rex. So it's boring to be excited by news like this. But for me, getting more in depth on this dinosaur, it goes back to the same thing about learning about their environment. The more information that I have about T-Rex, about what they look like, or sorry, not to call it just T-Rex now, but just the Tyrannosaurus species in general, the more I get to have a clear image of what their world looked like and what their existence was like. And if there were minute differences between species to species, even if that ranged between millions of years, is so freaking cool. And I love it. And it gets me so excited to just get a clear image on one of my favorite animals that ever existed probably looked like, and what its species looked like and what kind of world it lived in. So Guys, 45 minutes in. That's the end of this Dino live stream. Guys, this channel needs immense amounts of support, so I appreciate everyone tuning in. If you listen to this whole thing, I really, really appreciate you. I love any feedback on these live streams, so let me know how you guys felt about them. If you guys like them, if you're enjoying these live streams, especially those of you guys who watch them after, please give me some feedback. Let me know what you guys feel about them. If there's anything specific you guys want me to talk about, obviously type it down below. I'm going to remind you guys again, please go onto the Dinosaur channel playlist tab and just start playing a bunch of playlists. Get deep in the Dino Zones. I really took time to organize these playlists for you guys so you guys can see and learn about whatever dinosaurs whenever you guys want. So hop on in there if you guys want to learn about sauropods, ceratopsians, Jurassic Park dinosaurs, Jurassic World dinosaurs, Jurassic Park 3 dinosaurs, dinosaur quick dives, herbivore dinosaurs, carnivore dinosaurs. I organized it perfectly for you guys. So you can go in there and just binge like crazy. Even hybrid dinosaurs from Jurassic Park. We got 5 whole videos in there for you to just binge watch and learn. Let's see here. I'm going to read some of your comments. Hey, Tal, I have a question. What was smaller, Pro Compy or regular Compy? Oh, I actually don't know that off the top of my head. I think they were pretty similar in size, but if I remember correctly, I think Pro Compsognathus was the smaller one. But let's look it up. Let's just make sure. Pro Compsognathus or Compsognathus. Let's see. They have similar names, but no, they're not the same dinosaur. In fact, they aren't even closely related. Compsognathus is a Silurian compsognathed, and Procompsognathed is a Silophysid. Oh, so, okay, Procompsognathus is more similarly related to a dinosaur called Silophysis, which we do have an episode coming out on soon. Here we go. So we got Procompsognathus. I think I was right. I said Procompsognathus was bigger. Yeah, it was 4 feet, and Compsognathus was around 2.5 feet. And Procompsognathus being related to Silophysis. Silophysis is a Triassic dinosaur, one of the first dinosaurs that ever existed, probably that ever evolved. It's a really, really cool dinosaur. Highly recommend you check it out if you don't know about it. But again, we're gonna have an episode coming out on it very soon. We just finished the script for it, so probably in a month or so we'll have that episode out. Really, really cool dinosaur, really exciting, and the fact that they were related, similar lineage, it just goes to prove that that's a really, really cool animal and probably the reason why it's bigger. But really ancient dinosaurs. That's what's really cool about them. You should get recommendations to be in the next dino movie, maybe from your university in Hawaii. That's really cool. Appreciate that, guys. Well, anyways, I'm going to hop off here. Just want to remind you guys again to obviously subscribe, turn on the notifications for the Dinosaur channel, and leave us a dino-sized thumbs up. Comment down below a dinosaur prehistoric creature you would like to see us talk about in the future. And of course, if you can, please donate to our PayPal down below in this description. We would appreciate more than you can imagine. We need all the support we can right now because, again, may I remind you, we just invested too much money in a freaking Jurassic Park Jeep, but it's all about the content, baby. We're going to be creating amazing content for you on this Dinosaur channel. Big, big things are coming. We love you guys very much, and we'll see you in the next one. Guys, binge watch Dinosaur channel stuff on playlists, and we love you. See you in the next one. Goodbye, guys.